Example 9, we are given this diagram and asked to find the acceleration 1, acceleration 2, tension 1, and tension 2. We are going to say that this is the positive direction. Acceleration 1 refers to m1 and acceleration 2 refers to m2. However, they are both attached to the same rope, so we can assume that these two values will be the same. In order to find the acceleration, we must keep in mind that mg gives us a triangle, or the opportunity to form a triangle that shows us a parallel line to A. And that parallel line can be found with mg sine of theta. So the sum of the forces will include the tension, which is coming from the rope in the positive direction, so the tension will be positive, subtracted by the acceleration going in the opposite direction, or the force going in the opposite direction, which is represented by mg sine theta equals ma. T2, on the other hand, would be found using a different equation, because the tension on the rope is going in this direction, and the mg direction is the positive, which means the tension would be negative. So it would be positive mg minus tension equals mass over acceleration. And let me just write that this is referring to mass 1 and this is referring to mass 2. If we were to sum these two equations, the tensions would cancel out and we would have m2g minus mg sine theta equals m1 plus m2 times acceleration. And to isolate acceleration, we would divide m1 plus m2 to both sides, which would give us, I'm going to factor out the g so that we have m2 minus m1 sine theta over m1 plus m2 equals acceleration. And that is our equation for acceleration.